In this video, we're going to cover the first part of Prisms and review a little bit for the mid-unit test. So, to start off with, to review from previous lessons, remember that a polyhedron is a three-dimensional figure whose boundaries are polygons, meaning that its faces are polygons. So, and remember, a polygon, to be a polygon, it has to have at least three edges. It has to connect at the endpoints. Okay, so like a circle cannot be a polygon. So a square can be a polygon, and things that intersect in the middle, like this shape right here, is not a polygon because it intersects right here, not just at the edges. Okay, um, so polyhedron is a three-dimensional figure whose boundaries are polygons. Remember, the vertex, all the vertices are where the points meet. The faces are the actual polygons that mark the boundaries, and the edges are the lines that make up the faces. So, the definition of a prism is prisms are polyhedra, and polyhedra is just the plural of polyhedron. So we could also say a prism is a polyhedron with two parallel congruent faces called bases. Okay, so it's important that the two faces are parallel. So if we look at here, um, this one is called a rectangular prism because we classify a prism according to the shape of its bases. Now remember, a polyhedron we classify according to the number of its sides, how many faces it has, okay? So, but a prism we classify according to the shape of its base. So here, our bases are rectangles, so this is a rectangular prism. All right, and we're looking, remember, the bases are the two parallel congruent faces. All right, so these two faces are parallel. They're going in the same direction, so we would call those the bases. All right, here is a triangular prism, right, because the two bases that are parallel are triangles, right? These, look how these lines are parallel. This line is parallel to this line. This line is parallel to this line, and this line is parallel to this line, which means that these two faces are parallel to each other. Okay, this one is an octagonal prism because it has 8 edges. Okay, so it's an octagonal prism, and again, these are the two parallel sides, so that's why we call it octagonal. The parts of a prism are very similar to the parts of a polyhedron. Okay, the bases are going to be the two faces that are parallel to each other. Okay, so in this example right here, the two bases are going to be EFGH and then ABCD. And this one can definitely, the thing with a rectangular prism is that your bases could also be the other ones. It all depends on how it's sitting, though. We would classify with this, since this bottom it's sitting on A, B, C, D, that this is the base and that's the base. So with a rectangular prism, see, these two faces are also parallel, so those could be the bases depending on how the faces, depending on how the shape is sitting. But since this is the base, the lateral faces are going to be the faces that wrap around the base, okay, that make up the rest of the solid. So in this case, it would be EHAD, and then it would be EFBA, and then it would be FGBC, and then the last one would be HGDC. So those would be your faces. The lateral edges are just the edges that make up the lateral faces. Okay, so the lateral edges then would be line GC, line HD, line EA, and line FB. So those are your lateral edges, and then the vertices are just where the faces come to a point. So it's going to be one point. So The vertices then are going to be G, H, C, D, F, E, A, and B. So those would be your vertices. There are two types of diagonals when we talk about prisms. There's going to be the face diagonal, okay, and this one is the diagonal that cuts the face in half. All right, so remember the face then is going to be that outside part of the solid. So this line actually is on the outside of the prism. So it would be like if you drew a line across the face of a box on the outside, like on a present. A space diagonal is the diagonal that cuts the whole solid in half. So it's going to go from the front of one vertex to the edge of the back vertex. So here A is on that front face, C is on the back face. So it's going to go through the middle of the shape. All right, so that's why it's called a space diagonal, because it's actually cutting the space in half. So in order to find the lengths of the two diagonals, okay, if you're just finding a face diagonal, just remember especially in a rectangular prism, we're just going to use Pythagorean theorem. Okay, so to review, Pythagorean theorem is a squared plus b squared equals c squared. All right, so for example here in this bottom one, this G is a face diagonal and D is a space diagonal. So in order to find G, we would just take L squared, the length squared, plus the width squared, and that would equal G squared, right? We're just going to sub in those letters instead. So we could take the square root of L squared plus W squared in order to find G. Now, in order to find D, the space diagonal, it's a little bit harder because normally you're not given the measurement of the face diagonal. Normally on a rectangular prism, you're given the width, the length, and the height. So what we want to come up with is a formula that's going to help us find the space diagonal according to the length, the width, and the height. And so what we're going to use is this formula that we just found, right? The G squared equals L squared plus W squared, because look, G is a part of the space diagonal. Because in order to find this, D is our hypotenuse. So what we could say is G squared plus H squared equals D squared. Okay, but what we talked about is that we want to find D squared according to L, W, and H. Well, we already have H in this, so what we want to do is replace G squared, because up here we know that G squared equals L squared plus W squared. So what we're going to do is we're going to completely replace G squared with L squared plus W squared, and then we have plus H squared equals D squared. So that's going to be our formula. L squared plus W squared plus H squared equals D squared. And then to finish off that problem, we would take the square root in order to find D. So that is the formula that you're going to use if you need to find the space diagonal, right? And they are giving you the length, the width, and the height. Square all three of them, width, length, and height, add them together and take the square root, and that will give you D, the space diagonal. So for an example, on this one, it says which line segment is a face diagonal, okay? So the face diagonal is the one that cuts the face in half. So that would be AC. And then it says which line segment is a space diagonal. So the space diagonal is going to be the one that cuts the space in half. So it's going to be where it goes from the front bottom vertex, so that would be A, to the back vertex, which is G. Okay, so AG is going to be the space diagonal. So we want to find the measure of AC and AG. So remember, to find AC, right, we're just going to use Pythagorean theorem. A squared plus B squared equals C squared. So we're going to take our numbers and we're going to plug those in. So we're going to say, remember, this is A, B, and then this diagonal will be C right here. So we're going to say 8 squared plus 6 squared equals C squared. 8 times 8 is 64. 6 times 6 is 36. So we're going to take 64 plus 36, which is going to give us 100. And then we're going to take the square root of that, which is going to give us 10. So the measure of AC is actually going to be 10. So now we want to find the measure of AG, okay? Now here, we're given one of the edges, right, over here, 14. So we actually know that this is 14 as well, okay? Now we could do this two ways. The first way, since we just solved for C, we know that C is 10, so we could use Pythagorean theorem again, 10 squared plus 14 squared, and square root that. But we're going to pretend like we don't have this information because this is an extra step that you normally don't need to do. So we're going to use our formula that we made up earlier. The D equals the square root of L squared plus W squared plus H squared. So we're going to plug those in, okay? The length is going to be 6, so we have 6 squared, plus W squared, that's the width, so that's going to be 8, plus the height, which is 14 squared. So now we have 6 squared, which is 36, 8 squared, which is 64, and then 14 squared, which is 196. So that's going to give us the square root of 296. And then here it says round your answer to the nearest hundredth. So we're going to take 296 and we're going to find the square root of that, which is 17.20465. So it says to round it to the nearest hundredth, which is the second spot after the decimal. So if we look at that third spot, it's a 4. So it's actually just going to stay 17.20. So actually we can just write this according to the tenth because you don't have to put that 0 there. You can if you want, but you don't have to. So that's 17.20 centimeters. And just real quick, if we had done it the other way, right, we could have said the square root of 10 squared plus 14 squared, right, which would have been the square root of 100 plus 196, which would give a square root of 296. So either way would have been fine. But normally, like I said, you're not given this the face diagonal, so the quickest way is to use this formula right here. And that is the end of Prisms number 1.